Welcome to Mr. Waldal's math class. We are looking at the grade 9 Math Makes Sense textbook. We're looking at unit 2, and we are actually looking at exponents and power laws today, starting with lesson 2.1. Let me get rid of that for you. The question is, what is a power? What we're looking today is to recognize both when we see something that has an exponent, or a power as it's called, and then what that means so we can understand how to manipulate it within the different math equations that we're going to run across them in. So if you take a look, we're going to start actually looking on page 53 of the Math Makes Sense 9 textbook. So if you've got one to follow along, go ahead and open up there. And what they're talking about on page 53 is what a square actually looks like, or what sort of is the most common version of what you're going to see when people refer to those. What most people think of is when they see a number like this. So this whole thing is often referred to as a power. It's got a base number, which is the 5, and it has an exponent, which is the 3. Now, most people have seen these, especially by the time you've gotten to grade 9. We've run into them hopefully a couple times. But what do they actually mean? Well, that's what they're going to show you in the next example. So we'll move our slider out of the way here. So we start with squares. Squares is the easy one. So oftentimes you might hear people refer to things as centimeters squared, right? Or kilometers squared. It's often a measure that's used to refer to surface area and how much surface area something might cover. Oftentimes you can buy things like carpet in units of centimeters squared. But why do they call something a centimeters squared? Well, let's look at a perfect square like this, our handy dandy little example here. Let's pretend for a second that this space is 1 centimeter. Okay? So if that space is 1 centimeter, that means that this entire distance across here is 3 centimeters. It also so happens that our length here is also 3 centimeters. We know that area equals length times width, so if I were to find the area of that square, it would actually be 3 times 3. This is actually a bit of a unique occurrence. In most construction and all these different places where you might use something like centimeters squared, you're rarely going to get a number where the length and the width are the exact same. In fact, the only time that the length and the width are exactly the same is when you have a perfect square. So what somebody a long time ago did, probably when they were feeling lazy one day, is they wanted to find a different and a simpler way to write the mathematical equivalent of two numbers multiplied by themselves, same as you would find in a square. So what happened was 3 times 3 now became 3 to the power of 2. Okay? And what this is saying is that the base number is the number that's being multiplied. The exponent is the number of times it's being multiplied. So we can take another example. We can actually look at how this works when we're talking about cubes. The same principles at work with squares is the one that's at work with cubes. If we look at, oops, I forgot to put my pen down. If we look at our average cube, we're going to have, once again, let's go ahead and pretend that this is 1 centimeter. Okay? Since we have 1, 2, 3 on this side, we will call that our width, 3 centimeters. We have another 2, 3, we'll call that our height, is another 3 centimeters. And we will say that our 2, 3, our length is also 3 centimeters. If we want to figure out the volume of a cube, we know that volume of a cube is the length times the height times the width, which in this case winds up being 3 times 3 times 3. Just like with our perfect square, rarely will you ever find that the all 3 sides of a cube are exactly the same size. In fact, it only happens when you have a perfect cube. So, once again, if we have our lazy mathematician or whoever came up with this, however you feel like explaining it away, we decided that in order to make it a little bit easier to see and write, we could now write perfect cubes the same way we did the squares. 3 times 3 times 3 is the same as 3 cubed, where our base number here is the number that's being multiplied, and our exponent here is the number of times it's being multiplied. And with that, we wind up with 27. So what we have to look at here is what happens when we are dealing with numbers that aren't necessarily perfect cubes or perfect squares. So go ahead, and if you're still working with us in the textbook, go ahead and flip your page over to, it looks like page 55 here. So the way this will work is I'm going to do the first example of each of these different questions, and the expectation is that when you get to class tomorrow, or if you feel like doing it at home tonight for homework, you're going to do the other questions in there on your own for practice. So let's look at 4A. In 4A we have a square, forgive my drawing skills, a square with 2 on each side. 2 by 2 is how we would get our area, which is the same as 2 squared, because we're multiplying it twice. So you can pause at this moment if you'd like and try B and C on your own, or be ready to try them when we come to class tomorrow. Moving on, question 5A. So, question 5, we have the similar thing. This is going to be a particularly bad drawing, but okay. So we have a cube. It's again been drawn. Forgive my horrendous art skills. It has 1, 2, 3 units per side, and 1, 2, 3 units here. So length is 3, width is 3, height is 3, times 3 times 3 is the same as 3 cubed. So the way you solve these questions is you're going to count up the number of units that make up one side and the other, the length, the height, and the width. Put them into an equation, and then you can, oh, sorry. That was a bit of a brain fart. I have to edit that one out. 3 cubed, because the 3 comes up 3 times. So the way you do that, as I mentioned, is you count up the length, width, and the height. If they're all the same, and they should for perfect cubes, which is what we're practicing for this assignment, then you're going to write it all out, count how many times it comes up. You're going to wind up with 3 cubed. Let's move on to question 6. So for question 6, they want you to start doing some drawing. So we're going to do it in reverse. So if we have a what they're asking for is 4 squared, and they want to draw a picture that represents 4 squared. So now we're going to be doing our same process in reverse. So I'm going to write this out as a typical multiplication, which is 4 times 4. Okay? So that means I know that I have, in a perfect square, I have a length of 4, and I have a width of 4. So all I'm going to do is draw a square, and I'm going to mark it so that I have 1, 2, 3, and 4, 1, 2, 3, and 4 over there. So that is a drawing for 4 squared. For question 6, you'll have to, for questions E and C, you have to calculate out and figure out how many squares, what they're giving you for E and C is how many squares would be in a perfect square. And what they want you to do is figure out how big would the sides have to be for a square that has either 81 or 49 squares within it. So go ahead and give that one a try on your own. Moving on, question 7a. What they're looking for here is writing the base. It's very simple. All you have to do is identify. So if they have, for question A, a number like this, they simply want you to write out what is the base number. The base number is the large number that's going to be repeated as they multiply it. So for 7a, it is 2. Pause here and do 7, or be ready to do it in class tomorrow. Oh, I keep forgetting to put my marker down before I do that. Question 8a. Oh, went too far down there. Question 8. 8 wants you to do the exact opposite. So instead here, what they're asking you to look at it is to look at it and tell me exactly what the exponent is. So question A is 2 to the 5th power. So what they're looking for here is the exponent. So for that question, our exponent is 5. Take a second here to pause it. Go ahead and finish up the rest of question 8. Question 9. What they want you to do is break this down from an exponent into a multiplication equation. So if we start with 3 squared, well, we've already done this one before, but what they want you to do is write out the multiplication statement. So this one is going to be 3 times 3, because 3 is my base, so I use it here. 2 is the exponent, so I'm going to multiply it 2 times. 3 times 3. For our class, we're going to skip questions 10 and 11, and we're actually going to do the opposite process of question 9. So go ahead and move down to 12a if you'd like. Looking at the first question of 12a, it's asking us what 4 by 4 by 4 by 4 is as a power. Well, I know my base is going to be 4. And then I'm going to count up how many times is it used. 1, 2, 3, and 4. So my answer is 4 to the 4th power. Go ahead and finish up 12a on your own. The homework check for tomorrow's class, which is your assignment that you'll be working on, is going to be, oh, we did it again by accident. Page 56, questions 13 to 17. So be prepared to finish up the practice questions in class, and you'll have an assignment to work on, not for marks, but a homework check to work on. This will be homework checked for tomorrow's class. See you in class.